Section 1.4, solving inequalities. To solve compound inequalities and or graph their solution sets on a number line. Properties of inequalities. This slide is under resources on our group page. Properties of inequality is very similar to the properties of equality. We have a transitive property. In such a case, A is less than or equal to B, and if that is true, then B is less than or equal to C, then we know that A is less than or equal to C. Addition property and subtraction property, very similar to the properties of equality. If A is less than or equal to B, and I add or subtract them the same amount from both sides, then that A plus C is less than or equal to B plus C, or A minus C is less than or equal to B minus C. Multiplication property, very similar. We do have a little bit of change here. If A is less than C and we multiply by C on both sides, AC is less than or equal to BC. But that is if C is greater than 0. If it's less than 0, notice what happens, that the symbol changes. So AC is greater than or equal to BC when C is less than 0. And that is the same situation when we have the division property. We also want to recall that when we take a look at certain word problems, that when we have the term at least stated, that quantity is going to be greater than or equal to, but if we have a quantity at most stated, then that inequality is going to have less than or equal to. Here we have procedure for solving inequalities. They're very similar to solving equations. We want to copy the problem. Number 2, we want to simplify by distributing or combining like terms. Number 3, we want to get the variable or the variable terms on the same side by inverse operation. And usually that's by adding or subtracting. 4, we want to get the coefficient of the variable to be a positive 1 by inverse operation, and that's usually done by multiplication or division. And we want to recall here from the previous slide, when multiplying or dividing by a negative, the inequality symbol must flip, or in other words, it must change directions. Number 6, we want to graph and check the solution to make sure that we are correct. And remember, when we are graphing, when a graph has a less than or greater than symbol, we want to use an open point on the number line. In other words, it's going to look like this. We will not shade in the point. When graphing less than or equal to or greater than or equal to, what we're going to do is use a closed point on the number line, and that will look like a point that is filled in. Our first example, solve the inequality and graph the solution. Here we want to copy the problem. Negative 3x is less than 3 times the quantity of x minus 6. And then we want to simplify by the distributive property. Negative 3x is less than 3 times x, which is 3x, minus 3 times a negative 6 is a negative 18. Get our variable terms on the same side. So I'm going to subtract 3x on both sides. And when I do that, that gives me a negative 6x is less than a negative 18. Then I'm going to divide by a negative 6. That gives me x. And negative divided by a negative is a positive 3. But remember, from the properties of inequality, anytime that I divide by a negative value, I need to change the symbol, and this will make that x is greater than 3. I want to graph my solution. So I'm going to use an open point because this is not an equal symbol to, it's just greater than. So at 3, I'm going to use an open point. And then I need to shade all values of x that are greater than 3. So my solutions will be everything to the right. What I can do is select a point that is in my solution, and I'll select 4, the smallest one, and we can substitute back in to make sure that this is true. A negative 3 times 4 is a negative 12, less than 4 minus 6 is a negative 2. A negative 2 times 3 is a negative 6. And negative 12 is less than negative 6 is true. Therefore, my solution is correct. Our next example, let's copy the problem. And then what we're going to do is simplify by the distributive property. That gives me 12x. 4 times a negative 5 is a negative 20. Less than or equal to 6 times 2x is 12x. And 6 times a positive 3 is a positive 18. Let's get our variable terms on the same side. Subtract 12x on both sides. That leaves me 0 on the right, and 12x minus 12x on the left gives me 0 there, leaving me a negative 20 is less than or equal to 18. Notice our variables dropped out. So what we want to do is view what our solution here is. And it says that a negative 20 is less than or equal to 18. Now what we want to do is determine, is that true or false? Well, a negative 20 is less than or equal to 18, and that is true. Therefore, our solution set is all real numbers. In other words, we would shade the entire number line. What you could do to verify the solution is to pick any number on the number line and substitute it into the original inequality. For example, if I chose a negative 1 times 3 is a negative 3, minus 5 is a negative 8, a negative 8 times 4 is a negative 32. Less than or equal to, a negative 1 times 2 is a negative 2, a negative 2 plus 3 is 1, 1 times 6 is 6, and is this true, that a negative 32 is less than or equal to a positive 6? And the answer is yes, it is true. That verifies our solution. Our next example. Again, we're going to copy the problem, then simplify by the distributive property. Here, a negative 2 times 4x is a negative 8x. A negative 2 times a negative 6 is a positive 12. Less than or equal to, a negative 4 times 2x is a negative 8x. A negative 4 times a positive 4 is a negative 16. Let's get our variable terms on the same side. Here we're going to add 8x to both sides. On the left side, negative 8x plus 8x, that cancels, leaves me just 12. It's less than or equal to. On the right side, a negative 8x plus 8x, that cancels, that leaves me a negative 16. As in the previous problem, we want to see if this is a true or false statement. 12 is less than or equal to a negative 16. This is false. In the previous statement was true. And any time that our final statement is true, then our final solution is all real numbers. Any number can go into my inequality and solve the problem. But when it is false, that tells me there are no solutions. In other words, it's the null set. There are no solutions on the number line that can be picked that verify this solution to be true. We can test that by picking the number 1. 1 times 4 is 4. 4 minus 6 is a negative 2. A negative 2 times a negative 2 is a positive 4. 1 times 2 is 2. 2 plus 4 is 6. 6 times a negative 4 is a negative 24. And of course we have a less than or equal to. And 4 less than or equal to a negative 24 is false. So therefore, no numbers on my number line will satisfy this inequality. So anytime my final solution, when my variables drop out, is false, then I have an answer that is a null set. Anytime my final solution is true when the variables drop out, then I have all real numbers. Our next example, let's copy the problem. And let's start by simplifying the left-hand side by working inside the brackets and working our way out. So I'm going to bring down the 3, the bracket, 4x, distribute the negative 1 times 2 is a negative 2x. A negative 1 times a negative 7 is a positive 7. Close the bracket, bring down the less than sign. Distribute the 2 gives me 8x. 2 times a negative 5 is a negative 10. Let's combine like terms inside the bracket, gives me 3 times 4 minus 2x is going to give me 2x plus 7 less than 8x minus 10. Let's distribute on the left. 3 times 2 is 6x. 3 times 7 is going to give me 21. It's less than 8x minus 10. Let's get our variable terms on the same side, so I'll subtract 8x on both sides. That gives me a negative 2x plus 21 is less than a negative 10. Let's isolate our negative 2x, our variable term, by subtracting 21 on both sides. That gives me a negative 2x is less than a negative 31. Divide both sides by a negative 2. And our solution is going to be a negative divided by a negative is a positive 1x. And a negative 31 divided by a negative 2 is going to give me 15 and a half. And that will be positive. Recall from the properties of inequalities that when I multiply or divide by a negative number on both sides, my symbol has to flip. So this becomes a greater than symbol. Now you can see that my solution is x is greater than 15 and a half. My number line doesn't go out that far, so I'm just going to continue on with that and count out to 15, 16, 11, 12, 13, 14, 15, 16. Now, since this inequality is a greater than symbol, I'm going to use an open symbol for my point. Here I'm going to approximate 15 and a half with an open point. And since x is greater than 15 and a half, I'm going to shade to the right of 15 and a half, representing all values greater than 15 and a half. Our last example. A tax consultant earns $2,000 per month plus 4% of the sales. What must the sales be to earn a monthly income of at least $5,000? Well, what are we talking about here? We're talking about the monthly income, which is $2,000 without sales. We don't know what the sales are, so I'm going to let X represent the amount of sales. How do we find out the total income for this tax consultant? Well, it's $2,000 plus any amount of sales, and it's going to be 4% of those sales. So it's going to be 0.04 times X. That is the earnings for the tax consultant. Recall that 4% to change to a decimal is 4 divided by 100. Now with the last sentence, it says, what must the sales be to earn a monthly income of at least $5,000? Now previous slide said when we have a term that says at least, my inequality is going to be greater than or equal to, which means I have to have a minimum 5,000 and above. This sets my inequality. Now all I need to do is to solve. Let's isolate our variable term by subtracting 2,000 on both sides. That leaves me 0.04x greater than or equal to 3,000. Divide both sides by 0.04. And that gives me x greater than or equal to 75,000. And this would be $75,000. So for my consultant to earn $5,000, he would get his $2,000 plus 4% of $75,000.